Everyone. Good day. Good day, everyone. Welcome to Talent Talks by TalentsFactory. For those that have been joining us in our previous sessions of Talent Talks, we basically hold this event, Talent Talks. It's basically an event that is focused on helping the community, the Talents and Talents Factory community to be able to learn. So we invite professionals in the field to give us talks on certain topics in the tech industry. Previously, we've had talks on different topics that have really helped our community members to learning from professionals in this space, basically. Today will not be different. We believe that we are going to be learning a lot today. We have an interesting topic to learn about today. We all know how the world is a lot has changed recently with the introduction of AI, and a lot of persons have questions about AI, what AI really is. Of course, people have a bit of to maybe those who are already in tech, at least you have a bit of an understanding of what AI is, what AI can do, and all of that. But today we want to take it much deeper than just the surface knowledge. We want to talk more about AI, and we are going to be talking about agentic AI. What's agentic AI, and we're also going to be discussing the future of software engineering. There's a lot of fears, a lot of speculations around whether AI is going to replace software engineers or tech experts in the field. We are going to be having that discussion as to the future of software engineering, and not just software engineering. We are also going to touch base on other fields in the tech industry as well as to the introduction of AI and what the future look like for this field. So in the house, we have two professionals in the AI industry. We have Bello and also Sonny. These are experts, AI experts. They are AI engineers, and they have worked in the industry for over the years, and they have lots of experience. So they are going to be giving us talks on this. We have Bello, who is a senior AI engineer. He's going to be handling agentic AI, and Sonny, who is also a senior AI and robotics engineer, will be giving us a presentation on the future of software engineering. So for the first session, we want to welcome Bello, who is a senior AI engineer, to give us a presentation on agentic AI. Bello, you're welcome. Over to you.
Okay, yeah. So good evening, everyone. Thank you, Mr. Lawrence, for the presentation, for the introduction. Uh, Thank you very much. So, once again, I'm Bello, a machine learning engineer. I specialize in natural language processing and also general AI systems. So I'm going to give a presentation. So this is not too practical, but this is like this tells us about what agentic AI are doing, how AI systems such as large language models currently are able to uh, make actions such as turning the light on, such as searching the internet and all of that. So I will share my screen. Okay, so I think Mr. Lawrence, you have to give me sharing access. Can you hear me, Mr. Lawrence? So you have to give me a host.
Okay, yeah, just a minute.
Okay.
Yeah, you can share your screen.
Okay. Okay. So can everyone see my screen?
Yeah, yeah, we can see.
Okay. Yeah. So we'll talk about large language models and how they are also transforming into autonomous decision makers. So basically, we know large language model, what they do, they generate text alone or video or audio. So, but now how does it make autonomous decisions, such as taking actions? Uh, so, so the rise of agentic AI, what is agentic AI? So Agentic AI is just an AI system or large language model that is capable of performing actions. But before taking that actions, it thinks and also plan and act towards achieving a particular goal. So, for example, current state-of-the-art robotic systems that includes a large language model. You give the large language model a task. Okay, I need you to uh, take bring me the ball. So it's going to act with its environment and also based on the text that you set, right? So it will generate actions to achieve a particular goal. So the actions might not be just one, it can be different actions. So it will know that, okay, first of all, it has to work, it has to go to a particular direction and all of that before it achieve its goal. So how is it different from traditional AI language models? Uh, so we know chatbots and LLM, what they do, they just respond passively based on prompts. So that was earlier, um, starting from ChatGPT and all of that. What we know back then, those LLM are just able to give you a text response or image response based on your prompt, right? You cannot tell it to do an action uh, or to search the internet for you, right? You cannot tell it, okay, uh, search the internet, um, uh, list the best stock prices of the stock market. So now it doesn't have the ability to do that earlier. So now agentic AI have the ability, even though it's an LLM, it's incorporated with tools. So you give it a tools. What is that tools? A tools is it's those components that it use to make actions. Um, those tools can be different tools. For example, we'll have tools for searching the internet. We'll have tools for getting the weather forecast and a lot of things that you can also inject into that LLM system. So it makes independent decision. It uses tools and it rates. You can also give it the tools to write a code for you to create an application for you and also get a feedback. A feedback is it will also know that it makes a mistake. It will read the error and also reiterate solve that particular problem. So you give it that ability to use such a tool. Uh, so which is why it's different from the previous chat assistant LLM models. So why is this important? So it's important a lot because it enhances automation. It also reduces so by reducing human intervention in workflows. So for example, a software developer, a coding assist will have a coding assistant, right? Uh, but right now, you just tell it, okay, I need it to come up with a code base, or I need it to come up with a task that does a particular problem. It generates those texts for you, right? So you have to copy that text put it on your system, or just do anything you want to do with it, or create a, you will have to create a Excel sheet to put it. So those actions, you can put the tools for that. What does it do? The tools automatically, uh, that AI system have access to Excel sheets. So it will automatically generate the text, the information, and then extract it to the Excel sheet. And also in terms of programming, it will first of all generate the code base, and then it have an environment that is the code environment. So that is the tool. Now the tool is the code environment, right? So it will uh, run the code first. So when you run the code, it will look at the error that it's encountered. If there is an error, so it will have a feedback. So now that feedback is also a tools that will have to inject it back to the AI system, to the LLM model. Uh, so the LLM will also respond and give you your until it solved that particular problem. So you don't have to, so it reduces a lot of human intervention in workflows. So it also drives AI reasoning and autonomy. So it handles multi-step problems. So the previous example I talked about is a multi-step problem. First of all, you have to generate the code. You have to run the code base, and then you also have to inject the output to the AI system again. So it's a multi-step problem. So I can also tell it, I need you to search the city with the lowest temperature. Now, this is a multi-step problem, right? First of all, it will search cities on the internet, right? And then second, it will search the corresponding it will search the corresponding uh sorry. So it will search, okay, based on it will search the corresponding temperature of all the city. So it's different actions that it solves for you. Yeah, and also AI self-corrects and learns from failures. So based on the failures it encounters, now agentic AI are able to self-correct themselves until they solve a particular problem. So now we're going to talk about the evolution of agentic AI. How did we get to here? How did we get to agentic AI? Okay. It all started from how do we start injecting agentic systems with large language models, if I will be too straight. So started from the rise of attention by Google. So 2017 to 2020, attention is all you need papers. That was the first research paper on transformers, large language models, and then came to GPT-2, GPT-3, few short learning, and prompt engineering. So prompt engineering is just what you tell the AI to do. You prompt it to solve a particular task. Now, and then also chain of thoughts. So what is chain of thoughts? Chain of thoughts is problems, to break problems into smaller problems, and then you and then until you solve the main problem. So that's chain of thoughts. For example, you saw a mathematics problem or any problem, you want to chunk it into smaller problems, first of all, step by step. So we try to teach LLM system to do a chain of thoughts reasoning. So now, surprisingly, chain of thoughts reasoning also help the AI produce even better answer. And we can see examples such as DeepSeek R1 that was published recently, their AI system. It will be able to generate its own thinking, first of all, self-reflect, before it give you your response. So now those chain of thoughts, you train the LLM assistant model, you train the LLM system to create its own chain of thoughts, and that chain of thoughts will also guide it in generating your response to that AI, to the users. So, and then agentic AI frameworks like LangChain and queries and all of that. When it also know when to use the internet. I'm sorry, am I audible?
Yeah.
Okay. Uh, so integration of long-time memory and also self-improving agents. So now, in the future, more agentic solutions are even going to come in place. Um, to integrate long-time memory. Also self-improving agent that automatically learns by itself through its own action. Uh, yeah. So now how agentic AI works. Autonomous decision making, it select the best action for a given goal. If it has several actions to make for a given goal, it select which one to start first until it solve that particular problem. And then planning and execution, it plans, execute, and also refine strategy based on its previous feedback. Also, it retains long-term information. So it interacts with software, so which is tool use and also API calls. So I didn't talk about API calls. So API calls, you give the AI also these tools to be able to use any API that you can create to set to solve a particular problem. Payment systems, stock informations, API, and all of that. Also interacting with your database and also the web. So currently, you can see the chat assistants such as ChatGPT. Um, so ChatGPT you can give it access to internet. You can tell it to search the internet uh, or not. So improving as well over time and iterative learning. So AI improves over time as well. So also key technologies powering agentic AI. So Microsoft AutoGen, it's a collaborative system that you can join multi-agent system. So that means you can create a multiple AI systems that collaborate with each other to solve a problem. And Crew AI, it's also an orchestrating role-playing and also autonomous AI agents. So graph as well. So it's a graph-based reasoning for agentic workflows. You see how, so LangGraph, you will see how your agents are performing decisions um, to solve its particular task and also how they are collaborating. So OpenAI, I think all of the recent OpenAI models have access to tools that allows it to perform agentic tasks. So it can run your codes, it can search the internet and all of that. And we also have a lot of applications, a lot of companies that are leveraging agentic AI solutions. We know Devin AI. So it's a software AI engineer that entirely debug your code, create your code problems and all of that. So we have a lot of autonomous coding agent currently, Copilot as well, GitHub Copilot and all of that. And also we have the Anthropic AI models. So we also have customer support systems, AI-powered customer support. Yeah, an AI system that takes your call centers and perform analysis and content generations. So yeah, so I think in the future we will see a lot of agentic AI application collaborating as well with humans. So the future of agentic AI. So again, the future of agentic AI system, the trend now is to make an AI system that also learn from long-term interactions. learning by itself as well through feedback, and also multimodal AI systems. So LLM that integrates vision, speech, and also actions. So we have even seen it currently with the state-of-the-art robotic companies, such as Elon Musk robotic company. They have their system integrate LLM and also vision, speech to, and also autonomous action to perform a task. Higher autonomy in research and industry. So AI lab assistant and also real-time decision making. Ethical AI and regulation. So I think also in the near future, we will have stronger safety controls and transparency to create such AI systems. So I think it's going to be more and more uh, stronger next AI generations. And so ethical AI and regulation is a key thing to put in place. So challenges and ethical concerns. So now we know large language models have hallucinations and also reliability problems. Should you rely on such particular AI systems, LLM? Is it more reliable enough? Is it hallucinating? So hallucinating is just when your AI systems is confidently generating a wrong answer for you. So it's a major concern uh, to create AI system that ensure you have a fact-based decision making, and also ensuring truthful responses and actions as well. So autonomy also versus control. So you don't want your AI system to do something you don't want it to do, making unintended decisions. So it's also a major challenges in the current large language models. So how do you make sure that your AI system does not hallucinate and lead to performing catastrophic decisions? So also computational cost and energy use. So running AI agents require expensive GPUs and high energy. So I think current Facebook companies, OpenAI companies are using tens of thousands of GPU just to serve their AI models. So we also want to avoid bias, misinformation, and security vulnerability. So I think that uh, takes me to this is the last slide of agentic AI. So in the near future, we can also talk about, we can also show how they work in real time and go more into practical applications. Thank you very much.
Yeah. Thank you very much, Mr. Bello. Yeah.
Yeah.
All right. Thank you, Mr. Bello. That was a very interesting session. We were able to learn a lot. Personally, I learned from your presentation. Yeah, so thanks for that. So we are going straight into the next session. And for the next session, we have Sunny, who is also a senior AI and robotics engineer, take us on the future of software engineering. Yeah, so Sunny, over to you.
Okay. Mm. Yeah, thank you very much. Minutes. Okay. Now, can you guys see my screen?
Yeah.
Yeah, we can see your screen.
Okay. Okay. Thank you very much, Mr. Law, Engineer Law, for this opportunity. Yeah. So today I'll be talking about the future of software engineering. And one of the subtopic here is how AI and emerging technology are reshaping the industry. So if you can check very well, you discover for the past couple of 2 to 3 to 5 years, we have been having rapid change in the industry when it comes to like software engineering and the rest too. So, and that affects a lot, both layoffs and also increase in efficiency and new technologies into the system. Okay, now as a software engineer, okay, what is actually even software engineering? That's even one of even the basic things if every individual wants to talk about software. So software engineering is not just all about writing a code and the rest. Software engineering involves various aspects of engineering. So software engineering is far beyond writing the codes and the rest. It involves team collaborations, it involves product designs, it involves debugging, it involves analysis, it involves problem solving, SDLC, and the rest. So that's another thing about software engineering as a whole too. So now software engineering is far, far, far more than writing the codes. So now what's actually even changing? So when you actually even talked about the future of AI, so we're asking ourselves, what are the changes we have experienced for the past couple of 5 years now, since, let's say, since 2017 to this moment? So we have seen a lot of evolutions, a lot of emerging new technologies, down from large language models, and other areas of generative AI. So now the question we're supposed to ask ourselves, what's changing? What are the basic things that actually changed during this period? When we're talking about AI-powered code generation. So in this particular area, I'm just talking about strictly on how the future of AI and the revolution of AI is also affecting the software engineering and how it's actually both the positive and also the negative effects on in software engineering. So now, and most questions most people normally ask themselves is actually AI or revolution of generative AI taking our jobs? So that was also a very, very big question we'll be answering today from analysis and from an experience. So now, what is actually changing? So now, in this particular area, we're talking about AI-powered generations. So now, when you're talking about AI-powered generation, you're talking about collaborating tools. So as a software engineer, you actually have collaborating tools like Google Copilot, chatbots, which helps you in writing fast code, more efficient codes. At the same time, to also improve efficiency, then help you in doing some low-level codes, just some basic low-level codes in which a junior developer can actually make use of. So now you check, those are also an important area as a software engineer as well. So those are areas that changes and evolution. So if you check in this particular area of AI-powered code generations and the rest, so now in those particular area, you discover that we have a lot of benefits as a software engineer on those particular area, where you have a chatbot that can actually give you a real-time solutions to your problem. But now the chatbot systems and the Copilot systems, they automatically make suggestions for you, not that they're actually doing the whole work for you. So you are actually the main brain box of any kind of work you do. So what the basic thing the chatbot systems or the Copilot systems are actually doing, they're actually making suggestions for you, also giving you auto completions and all those kind of stuff. So now one thing about the Copilot systems in those particular area, now Copilot systems are actually designed to reason the way you write your codes. So that was another very good thing about Copilot systems. So we have various Copilot systems even in our various modern laptops, modern PCs, and the rest. So now all those smart systems, all those smart technologies that actually help us to write code more efficiently, and also very fast and proficient in every kind of code you actually want to write. Now, when it even comes to like, okay, low code and no code platforms, now those are some of the areas we also look into considerations. Now, you discover that most businesses now adopt to allow no programmers to build applications, reducing the demand of traditional coding in all those particular areas. So now there are some businesses that actually want, there are some businesses, in most of those businesses, they prefer collaborating with platforms that does not actually have codes, or prefer collaborating with platforms in which all those solutions, ML solutions, AI solutions, or some of their business analysis can be done without them actually even employing the software engineer. But you discover at the same time too, there are some little side effects. So those are some of the areas it also affects. But in those kind of areas, not that you're actually eliminating software engineers totally from those particular areas. Because let's assume in the case where you're working in the business environment, and they have, let's say, most businesses, most of them actually have their websites, which is actually managed by their engineers, both their front end and back engineers. So just imagine a business actually have, let's say they have 6 engineers. Let's say 2 actually handling the front end, to have the ML engineers, to have the back end engineers, and the rest too. So now, if those companies actually want to make improvements, want to do some 1 or 2 things to make more efficient, definitely you discover that even when it comes to like analysis, in some cases, when it comes to like analysis, we discover that those AI models actually predict and make good analysis for your business more than human in some cases. At the same time, to another thing about human efforts, we're talking about humans actually prone for errors. So definitely some errors matter, but when it comes to like those smart AI systems, you are not bound to get some errors in some basic analysis. But when it comes to like involving human in tackling those kind of problems, you discover that you have problems. Now, as a software engineer, in those kind of cases, if the company actually want to increase their productivity, want to increase efficiency, definitely they have to like collaborate with those AI systems. They have to like collaborate with those platforms that render those kind of services. Now, definitely in some of in those particular areas, not that they'll eliminate their software engineers totally. No, definitely there might be something like a layoff. So assume we have like 6 engineers and they have like a layoff of 3 engineers out of the 6, or they have a layoff of, let's say, 2 engineers out of the 6. Definitely, those are some of the side effects you might be doing. Now, one good thing about evolution when it comes to like technology as a whole too. Now, technology immediately it replaces some jobs. Immediately, and some of those AI systems replace some jobs. I normally say this due to my research and experience. It creates more jobs in future compared to the number of jobs it layoffs. So now, assume an AI engineer, an AI system will actually, or any AI technology, we replace, let's say 2 or 3 jobs and the rest. So in the near future, it will provide more than hundreds of that particular jobs that you actually even replaced. So that's one good thing about technology. It does the same effect we actually have when we're using landlines, Nitel in Nigeria cases. We actually make use of Nitel. So when the GSM system came, everybody was just shouting, wow, it's actually taking jobs. Yeah, they were lay off. It disrupts the telecommunication industry at that particular point. Yes, but in subsequent time, it creates more jobs than even having just the Nitel engineers around, Nitel and administrators and the rest too. But at the same time, in the long run, GSM actually makes revolutions. Yeah, we have people who sells recharge cards. We have people who repair phones. We have people who change screens and the rest. So you discover that in the long run, that actually even create more opportunities than the number of. Now, if you check from the analysis, we discover that the number of employees, the number of employers we actually have when it comes to those jobs and people we lay off during those era, you discover we'll have more opportunities now than even the number of people it actually plays. So that was one good thing about an AI system and revolutions. No, it's not just like it's actually taking your job totally. Yeah, it might actually take some jobs to improve efficiency and also improve business. Now, in areas of businesses, every business actually want to make a profit. and also want to get more efficiency. So now, if you actually want to go for profit and efficiency, definitely you have to do whatever you need to do to actually do that. So those are some of the areas where layer comes into place. Now, one good thing about agentic AI and revolution of AI, which the future of software engineering and solution of software, we're talking about agentic AI. So now agentic AI is just like a tool for you, just like as a farmer, you have the best mechanisms, you have the best infrastructures, you have the best machines to carry out a particular task. You have an automated system to carry out a particular task. That's what an agentic AI is actually bringing into the system. So as a software engineer, you are not supposed to be thinking about how to write codes always, how to be at the background. So you are at the point where you have your food at your mouth. You are at the point where you have the thing you need to create a solution. So in the area of this agentic AI, it's not just all about writing the codes. That is one good thing about the area of this agentic AI. The area of this agentic AI now, as a software engineer, is just for you now to create a solution to solve a problem. You have a tool where any kind of programmer, even though you're a software engineer or non-software engineer, with those kind of technologies, you can actually create a new solutions that can benefit the whole world. You can create a normal real world solutions. So those are some of the areas when it comes to like agentic AIs in this particular area. So now, as a software engineer, there are some basic things you are supposed to focus on at this stage. Yes, if you actually want to go with the trend, because now even we as a software engineer, as an AI engineer and the rest too, it's not actually easy to catch up with the latest technology. Yes, because every blessed day we get new research papers. You can't actually read the whole research paper. It's just for you now to just, okay, understand the basics of the latest technology, how it works, the approach they use in making those improvements and the rest too. So now the AI system and the AI environment, the technology space, the software engineering space, it's actually moving at very high pace with this generative AI and the kind of solutions it works. So now as a software engineer, some of the basic areas you're supposed to focus on is system designs. Now, as actually even say, software engineering is just all about writing the codes as well. So it involves system engineering. And from the last video I actually worked about where Engineer Lawrence was actually talking about how he solves problems at times when actually having some difficulty, he will just go off for some time. So when he's actually doing one or two times to work or something, an idea or solutions. And again, he actually mentioned, okay, and before he actually even moves to his workstation and the rest, so he normally sat down, reason. And so those are the areas where problem solving also comes into place, system architectural design and the rest. Like for me, if I'm to solve a particular problem, I normally spend 60% of my time in system designs, in problem solving, knowing the best things. So that's one thing. Coding these days is not actually a difficult something for individual to learn. At the same time, even in a week with a high level dedication, you can actually learn a new programming language. And as a senior software engineer with so many experience, it takes just few days for any software engineer to actually, not any software engineer, senior software engineer or mid software engineer to actually learn a new programming language. So now when it even comes to like coding, now coding is not actually even the problem. Now the major thing when it comes to like software engineering is system designs, problem solvings, algorithms. What are the basic things you need to know? You're supposed to know the fundamentals. So those are the areas where your fundamentals will come into place. How do computer reasons? How do machines reasons? How do this programming language react to and those kind of stuff? So those are some of the areas too as a software engineer. So at this stage of software engineering, you're not supposed to be focusing on programming language at this stage. You're supposed to focus on non-coding areas as a software engineer. If you check when you come to like job applications, even as a you see some job descriptions, they'll be looking for, let's say, a front engineer or a back engineer. But at the same time, too, and those back engineers, they'll also be demanding for an AI engineering experience as well. And those things. So you discover that the demands for diversity when it comes to like for engineering roles is actually very much these days. You discover that you see you want to apply, okay, as a robotic engineer, one basic thing as a robotic engineer and experience when it comes to that. So most of the job descriptions you see, you discover, okay, you need an experience in computer visions, you need an experience with robotic systems, you need an experience in Linux-based systems and the rest. So those are some of those areas and all those kind of solutions come. So as a software engineer, you are not supposed to just focus on writing codes alone. You also focus on areas, those other areas, debugging, and automating systems, and different types of software engineering solutions, designs, and the rest. So one of the basic areas as a software engineer, we are supposed to even focus more on, emphasize more on system engineer and system design. So your system design is one of the basic steps you take before actually even writing your codes. So the kind of architecture you design, the kind of system architecture you design will actually determine the efficiency and the performance of how your solution come into life. Now, at the same time too, another good thing about evolutions of this AI and how it's actually affecting software engineering as well too. Now, in most of these cases, you see some companies, they lay off some staff, not actually lay off a staff for a particular task. Yes, you have various areas of software engineering and various departments in software engineering companies. Now, they don't lay off their staff totally from a particular role. They might just reduce some staff. So now, most of those staff, they replace them with collaborating softwares and tools. Yes, like co-pilot and the rest. So now you discover there are some organization where your co-partner might be an AI agent. Yes, okay, we might actually have an AI agent to be doing some one of the tasks. Okay, let's say like in the case of Figma, the AI generation Figma. So just imagine in those particular kind of cases now, you as a backend engineer, what you actually need, you just actually need your designs. When you get your designs, you feed it to Figma, it generates the code for you. It's just for you now to write and interact. So now, not that you're actually replacing the front engineer alone 2 years. You're just if you're also having a team of a front-end engineer as a robot, which also give you efficiency and very good and rapid response in solving solutions. So those are also very important areas as a software engineer you have to. So now, then the rise of AI engineering. So like the rise of AI engineering, which I actually even talk about the AI tools and streaming codings. Yes, we have AI tools, streaming coding. Yeah, we have like the GitHub Copilot, Devin, chatbots, and the rest. So there are also AI assistant that helps us to write code faster. At the same time, too, they also code auto completion, box fixing, refactoring, documentations, all those kind of systems. Like, okay, like for me, I actually make use of JetBrains applications like the PyCharm and the rest. So they're also very, very good. They have their own AI system, Copilot system incorporated in those kind of systems. Now, those Copilot systems now, and the way you actually program, the Copilot system now understand the way you program and things. So now it makes suggestions based on the way you also program. At the same time, it also reads your code, understand the way your code works and the rest. So also understand the way you previously programmed some things, understand the way you reason in some of those particular areas. So it actually makes suggestions for you, not that actually writing your code for you. No, it also makes suggestions for you automatically in those particular areas. So now, and some of those areas where AI system actually being replaced, where human actually replaced by AI system. Those are all those repetitive tasks and those some basic low-level tasks. Yes, all those simple low-level tasks. And mind you guys, at the same time too, and all the generative AIs we have seen, we don't have 100% efficiency when it comes to like writing of codes. You don't have 100% efficiency. We have not gotten to the stage where our generative AI or our chatbot system or our AI agent will actually give us 100% of anything and with full confidence. We have not gotten to that stage yet in those particular areas. So if you're a software engineer, you are scared of your job will actually be replaced. We have not gotten to that particular stage and the rest. So now, at the same time too, we also ask ourselves, now those generative AI, did not generate themselves. So they're also actually generated by scientists. They're also designed by individual, by human being and the rest. So now we are also more superior than them in most cases. So, and if you check most of all those systems, and I think there are some debates that involves generative AI doesn't reason. Yes, there are some facts. Yeah, there are a lot of facts and debates. Yes, you don't just talk about reasoning. Now, this is how AI models actually being trained. You feed them data. So most of all the generative AI, you feed them the data on the internet and the rest. So what they actually do is just search from the internet, from the database, from what they're actually being trained, extract some very vital information, reason around those particular information. But when it comes to like real world reasonings, like make some kind of drastic decisions, your AI systems can actually even do that for you. Now, even there are some cases where you have collaborations. So they're also not very good at collaborating as well too. So there are some cases where you're actually having a board meeting, or a collaborating meeting and this. So there are some kind of like vital questions in which individuals ask some kind of creative questions in which your teammates or your colleague might actually even ask. So those kind of AI systems can actually even do that. So when it comes to like creativity, that is where we are more superior on those particular areas. So most of the places in which those are just repetitive tasks, most of those areas in which those AI and systems also. And if you check, so most of the role, due to the effects of evolution of generative AI, the evolution of technology when it comes to like software engineering role, so most of the jobs that are actually being replaced, most likely, if you check from my statistics, if you check from the internet, you hardly see a junior role. In most cases, most of the roles you see are internship, and most internship roles are not actually really that much, but it's not something like to scale. So those are some of the areas in which our AI system and evolution of AI systems are also affecting we as a software engineer and the rest. So now for you now to actually beat those particular tasks, you have to like move with the trend. You have to learn new things. You have to read research papers. So those are some of those basic things. So we check most of all these AI systems. Now now in a case where you actually want to work in a company, now those company now, in a case where you actually work in a company, now most of those companies they are dedicated for a particular task. So just imagine you're working in a business analysis company, or you're working in an agricultural engineering company. So they are designed to work to solve a specific areas of engineering, which is agriculture and the rest. Now, if you actually want to design a system, you design a system to solve that particular task. So all these AI agents are being designed to solve a particular task, to solve a constant task. So those are some of those areas. But if you want diversity, you want to like, okay, the company want to improve and the rest, definitely they'll need to like redesign those systems. So definitely they also need an AI engineer as well too, or a software engineer to actually solve those problems. So you discover that you're not actually you're just like human in the loop as well too. You're also collaborating, working with those AI systems. And some of those basic area in which you they normally replace are all those low-level codes, those simple codes in which most junior or intern engineers try to solve, those crude database and system management systems and the rest, and some simple API design applications. So those are some of those basic areas in which okay, then now, so we are actually still at the rise of AI in software engineering. So now AI excel at repetitive tasks, but lacks creativity and decisions. So that was also very important as an AI engineer. So now when it comes to like repetitive tasks, just like normal constant tasks, and AI is designed for a particular task. So they are very good at those particular tasks. They improve as and one of our engineers said, Mr. Bello, said, now those AI systems, in long run, most of those agentic AI systems some type of agentic AI systems. In the long run, they also make improvements. They also understand your business. They also understand the customers and the business owner decisions, and also improve and see how to actually make it work and better. So now those are repetitive tasks in those particular areas that are designed for a specific task. So they constantly solve solution on that and specific tasks. But when it comes to like creativity, making new decisions and the rest, so those are where human actually involves. And for you now to actually make for you now to make an improvement to overshadow those technologies, now that's when your creativity level needs to come into place. And how do you, as an AI engineer or as a software engineer, how do you increase your creativity? By reading research papers, by being up to date with the latest technologies, by trying to get more details about software engineering and understanding your fundamentals when it comes to like software engineering and problem solutions. So now AI excels at repetitive tasks, but lacks creativity and decision. Then AI can't think critically. So those are some of the side effects. Those are some of the loopholes and you have for AI systems. So and those are some of the areas as a software engineer you can come into place in those kind of areas. So they can't think, they can't make complex software designs and solutions. That one is a fact. Yes, you can actually build a complete, robust, flesh system from your chatbot. Let's be honest about it. We actually make it. So most of the chatbot systems we use them to build a Unity subsystems. They're just like a normal collaborators and the rest. Okay, we made the decisions. We prompt them on what to give us, and most of the things they actually want as there's all called hallucination as well too, where your AI confidentially generate wrong answers for you. So it's not just every code you see the AI generates is actually right. You can run at the same time the AI system the code generated might actually meet your specifications, let's say in performance or in latency or the responsiveness of those particular solutions. You discover those AI systems can actually meet all those stuff. So those are where your human analysis involves. You see people make a new architecture designs every blessed day, a new robust architecture design almost every blessed day. So those architecture designs are not designed by AI systems. Those are designed by engineers. So those are where creativity as an engineer come into place. You stand out from the whole product. Now, then other areas as a software engineer, you're supposed to like focus architecture planning, problem solving, business logic understanding, and the rest too. Then at the same time, engineers are also still need for high level design, debugging, AI generated code and ensuring software to meet user needs. So these also talking about collaboration and so as an AI engineer, sorting algorithms, you're supposed to understand one or two basics and algorithms. So those are some of the basic key areas you're supposed to focus as an AI engineer at this trending area: system designs, problem solving ability, know much about fundamentals about coding, at the same time, understand the operating systems. So those are also very important areas most people actually don't understand. Understand operating systems, how they work, how different operating systems, how those particular operating systems interact with your codes and the rest. So what are the best programming language to use to solve these particular tasks? So those are some of the areas as a software engineer, you also need to like focus into those areas. So you're not supposed to, we are at the stage where totally you might be eliminating areas of writing codes, a large chunks of codes. You might actually have an AI assistant to be helping us to write some part of the codes, not like writing the code totally. So now we are supposed to focus more on the creativity. We are supposed to focus more on problem solving and the rest. So as I said earlier, we are at the stage where we are giving the tools as AI agents is the future. We are giving the tools. So I'll normally advise software engineer at this point, you're supposed to focus on solving problems. That is at this point. So at this point, you're supposed to focus on solving problems. You have all the tools it takes for you now to make product. So what's as a software engineer at this stage and at the stage of evolution we are on software engineering, we are supposed to focus more on creativity. We are supposed to focus more on we solving problems. We have the tools, so not just to write codes at this point. Then now coding is just about 30 to 40% of software engineering. Yes. So now the major reason now let me just use this analogy. Now you discover that in an industry, let me just use an engineering industry. So now in an engineering platform, like engineering company, you discover that the designers are paid more than the skilled worker, than the normal staff. Okay, let's assume, okay, you are at the site, let's say building site, the architect actually pay more than those laborers working at that particular point. Now you'll be asking yourself, those laborers actually working more. Those are some of the analysis and normal and average human actually reason. Okay, those laborers actually working more than even the architect and the rest too. But now it's far, far, far more than that. Creativity. So those are the areas in which creativity. So those workers are just like you writing codes. So the major brain work behind those parts are creativity. The major brain work behind the design are the architect. So they bring a solution. Without them bringing those solutions, you won't have anything. You won't have any laborer to work. So a laborer cannot just come and build a skyscraper just like that. So it doesn't work that way. So definitely they must have a designer. They must have someone who actually bring those particular stuff. So now before you actually start building anything, you're supposed to have a design. You're supposed to make some basic analysis. So those are some of the areas in which you are supposed to focus on. So we're supposed to focus on how to solve a problem, how to create new solutions. You're not supposed to be focused. So as a software engineer, you're not supposed to focus fully on learning different programming language at this point or on the rest too. So now we are supposed to focus more on those particular area of creativity. So now when it comes to like software engineering, you're talking about 30 to 40% of software engineering involves coding. Then you're talking about 60 to 70% involves different areas, which are talking about system architecture design, communication and planning, which is also very, very important, problem solving and decision making, optimizations, which is also very, very important. Like for me, I love optimizations very well, system design and optimizations. So they're also very vital. Another very good thing most people neglect a lot are algorithms and development. Yes, algorithms. So now know the best algorithm to solve a problem is also very, very important. So don't just use a generalized algorithm. Try to get a unique algorithm, a more efficient algorithms. Every blessed day you see different research papers on specific and solutions. So you read research papers, you like, okay, I think those are one of the basic things. Most software engineers don't actually put their energy. So if you actually want to be a very, very good software engineer, actually want to go with the trend, always learn to read research papers. If you're a software engineer, even though you can't actually even try to at least implement 1 or 2 research papers. So the key area of software engineering, even at this point, try to read research papers. They're very, very important. Try to know the latest technology. Try to know the latest methodology that a software engineer to solve a particular task. So then we're talking about model inferencing and serving and the rest. So now, if you check when everyone comes to the job descriptions and opportunity, you discover that in most of the job description, they'll tell they need someone with MLOps. Doesn't even as a software as a normal front end or a back end engineer, they'll tell they need someone with MLOps experience and the rest. So now, most of all those companies are not just looking at how good you are in writing a code. They're also looking at other areas in which you're also supposed to be very good at. Now we are talking about model inferencing and serving, which is also very, very vital. So there are some companies, like most companies these days, they're just looking for those who are very, very good in model inferencing and serving. Yeah, we have AI models. Now, to train AI models is very, very expensive. Yes, due to from the analysis and everything. Yes, to train an AI system is very, very expensive. It's very, very expensive. So now as an AI engineer or as an AI researcher, we don't actually have those amount of money. We don't actually have those amount. Even OpenAI also get funding as well too. Not that they generated the funding themselves too. They're actually even running at loss. So now they have funding. So to actually train an AI model, to actually even build an AI model also entails a lot of resources like GPU rentings, and also getting researchers to actually design new architecture design. So now, as a software engineer, what you're supposed to be focusing on, how do we deploy those models? So those are some of the areas we are supposed to be focusing on. And one good thing about generative AI, there's what called encoders and decoders. So you check most about LLM, large language models. Most of them involve encoder, decoders, and the rest. So now, for some of those areas, so those are some of the areas you're also supposed to look. What are the various architectures that you can actually design? So what are the frameworks you can use to actually solve in the area of serving or deploying AI models? So those are some of the areas too. As a software engineer, you are supposed to also understand. Then, as I said earlier, reading of research papers is also very, very vital, which is very, very important as if you actually want to move with the trend in those particular areas. So why is it important? So adapting to the changing in the industry. So now, to stay relevant, competitive software engineering must, one, embrace the AI tool rather than fear. Yes. So now, okay, let me actually even give an example of how it even works in some of those cases. Now, most of the times, if I actually want to work on a system, let's say on a new framework or on a new API systems. So what I normally do most of the times, I go to their site or download the documentation and upload that documentation to a new chat, let's say either on Gemini or on ChatGPT and the rest. Now those chatbot systems, those generative AI now will understand the basics on those documentation. It will actually even give you more insights on that particular documentation. Now, at the same time, now you discover that now it will improve your response, and it will also make your productivity very, very fast at that particular time. So you can actually interact with APIs, interact with frameworks, and you actually get your results. And there are some also other approaches I also make use of. If I actually want to work on a particular class, that I know it, okay, you check that particular class, you discover that you have like hundreds of methods in those particular class. I can just copy the whole class as a whole, put on the chatbot, and tell the chatbot system or tell generative AI to explain all those systems in details, because it's actually easy for you to sit down. Let's say you're talking about 10,000 lines of code, for you to understand those 10 lines of code easily. But when you have those systems, you can just copy that particular whole chunk of code. The AI system will try to explain those steps, and it will understand the whole code, and you can actually interact and get a specific answer in which you're looking for. So those are some of those areas too for you to be at the top of your game. So, and again, to the other area, develop strong system architecture and design skills, which is very, very essential as a software engineer. Is very, very essential. Now, one good thing, as I'll normally advise for all software engineers, you're supposed to learn system integrations as well too. Now, as an AI engineer, I have some basic experience on backend as well. Also have some basic experience on front end. Also have some basic experience on other areas as well too. So now with those kind of systems now, you can actually design a robust system. You can design a robust system architecture that will also serve you, or also serve the job description or the user description on those particular stuff. Then improve solving, collaboration, and ethical considerations in software development. In the future of software engineering will not be about who can write code, the most code, but can think critically, solve complex problems, and leverage AI to build a better systems. So those are these key areas. So now let me read it again. The future of software engineering will not be about who can write code or who can write the most code, but who can think critically, solve complex problems, and leverage AI and systems. So those are some of the areas. Then preparation for the future, embrace live learning and continuous improvement, like reading or research papers, learn new frameworks, learn new programming language, the latest programming language to improve efficiency. Then develop expertise in AI, yeah. Let's say using of different AI APIs, open AI APIs, understand some of those basic models. Then cloud computing is also very, very essential. So I get into a stage where as a software engineer, you are supposed to know those particular systems, even learning Linux operating systems, which is also like an essential at this stage. Then cyber security and any form of security system. Then the last part, stay adaptable and ready for industrial shift. So now, my final thoughts for this particular stuff as software engineering will evolve, but the demand for skilled engineering remains. So those are, as a software engineer, you're supposed to put into consideration. Definitely software engineering will evolve, but the demand for skilled engineers will remain. So now definitely the competition will be there, but now for you now to focus your energy at some of those areas in which I just mentioned, you're supposed to put your energy. Then those who innovate and adapt with thrive. Now, as I said earlier, one very good thing we're supposed to embrace as a software engineer at this point, you're supposed to embrace on solutions. As a software engineer, you're not supposed to just be thinking about writing the code or doing this. At this stage, we have the tools to do whatever we want to do. So what we're supposed to focus on, we're supposed to what? Focus on what? Solutions. That is another area as a software engineer. Then keep learning, keep building, and embracing the future. So that was it. Thank you very much. Yeah, Kenneth.
Thank you. Thank you. Sonny, that was an amazing session. We learned a lot. Personally, I learned a lot through your session. The way forward for software engineers, what we need to do to be able to stay relevant in the field and stay competitive as well. Yeah, so thanks a lot. Got a lot of points from your presentation. So we'll be moving to the next session, which is basically question and answers. So if you have any question based on the presentation for both sessions, the agentic AI and the future of software engineering, you can drop your questions in the chat section, chat box on YouTube, and we can answer the question. So if you have any question, you can drop the question in the chat box and we can answer the question. Yeah, so just to highlight some points from Engineer Sunny's presentation. Yeah, so AI is doing a lot of amazing stuff, but for us to, especially software engineers, to stay relevant in the field, there are things we need to do, there are things we need to optimize in terms of skill sets to be able to stay relevant, right? So there are things, in as much as AI can do a lot of things, there are some things AI cannot achieve, right? So as software engineers, we can focus on things like system design. Of course, an AI agent may not be able to design a system from beginning to end. Of course, it may give some ideas based on prompts that have been given, but it will still need human intervention, right? And then also, software engineers embracing AI as well is a very important fact, because if you have knowledge of AI, I believe that it will position you better as a software engineer, right? So you'll be able to work on, a lot of companies are going to be hiring engineers to work on things like agents, AI agents, and so on. So as a software engineer, if you learn agentic AI, how to build AI agents, I believe that it's going to position you better as a software engineer, right? So you can work as a regular software engineer. You can also work as an AI agent as an agentic AI engineer, you'll be able to build agentic systems and so on and so forth. Yeah, so still looking out for questions. If anyone have questions, you can drop those questions in the chat so that we can answer the questions. So far, we haven't received any questions, so I'm assuming that there's no question from the audience. So it's been an amazing session. We'll be able to learn a lot. It's good to have you join us for today's edition of Talent Talks. We dealt a lot with agentic AI and the future of software engineering. At TalentsFactory, we are committed to helping people develop skills, grooming talents, basically helping people to become better in terms of tech skills. We also have a training for a bootcamp coming up in April for agentic AI engineering. So those who want to learn how to build AI agents, we are going to be holding a 9 weeks bootcamp, and that bootcamp is going to be taking us through the journey of building AI agents. So as a software engineer, you want to transition or you want to acquire some AI skills, it's a good opportunity for you to sign up to be able to learn. So you can visit our website to be able to sign up for the bootcamp. And also, we also advise you to, for those who are joining us and haven't subscribed to our YouTube channel, you can subscribe so that you'll be able to get notifications when we go live with sessions like this, because Talent Talk is an ongoing something that we're going to be doing from time to time. We'll be having talks on different topics, right? So yeah, it's important that you subscribe so that you get notification, get reminders when we go live with sessions like this. Yeah, so since we don't have a question, this is where we end it for today. Thanks a lot, everyone, for joining us, and have an amazing.
Thank you for the
Yeah,
opportunity.
thanks, Sonny.
Yeah. Bye.
Yeah.